Okay, today we're going to be looking at multiplying and dividing radical expressions. Before we had been looking at simplifying and a couple of different cases of that. Today we're going to be adding something to that. We're going to be multiplying and dividing, but honestly the majority of what we're doing is still going to be simplifying. The actual operation is the easy part. What we've done before, if that makes sense, that's harder than the new stuff. So let's take a look at it. We have one main rule when we're multiplying or dividing, and that is whenever we're multiplying or dividing, we combine the numbers that are outside of the root symbol together, and then we combine the numbers that are inside of the root symbol together, and these are done separately. So you only multiply or divide the numbers that are outside together, and you only multiply the numbers that are inside together. We don't cross back and forth. It's only the outside ones and only the inside ones. You should also need to remember your rules for multiplying and dividing exponents. Remember, if we are multiplying two bases, two of the same base, we need to add the powers together. And if we are dividing two things that have the same base, we need to subtract our powers. And we'll take a look at that when we see some of the problems here. Okay, so first off, individually, these look pretty similar to what we had been doing, but now we're multiplying them together. And our main rule that we just looked at said that we need to multiply the numbers that are outside together and then multiply the numbers that are inside together, and we do those separately. So for starters, we just do 2 times 4, which is going to give us 8. So we're going to start out with an 8 outside of our square root. We want to multiply our numbers inside together, and if I multiply 3 times by 27, that'll give me 81. So I've got 8 outside the square root, I've got 81 inside the square root, and now I need to multiply my x's. When I multiply x to the 5th times x to the 6th, I need to add my 2 powers. So I add 5 plus 6, which will give me x to the 11th. Now, since we're dealing with the square root, we need to look at our chart for square roots to check this for simplifying. And if you look at that chart, you notice that 81 is a perfect square. That means 81 doesn't need to be split up. We can leave that by itself. So I'm going to have this 8 here. I'm going to have my square root of 81. And then with this x to the 11. Since my index is not shown, that counts as an index of 2. And I know that I can't divide 11 by 2 without getting a fraction. So I have to split this 11 up. And the way that I'm going to split it up is I'm going to split it up into x to the 10, x to the 1. Just like that. I'm going to write that a little bigger. All right, hopefully you can read this line a little bit better. It's the same thing. So we've got 8, square root of 81, square root of 10, x to the 10, and square root of x to the 1. Now we want to simplify. So I've got 8. You don't need to do anything with that. We just bring it down. Square root of 81 is equal to 9. No more square root for that. Right here, square root of x to the 10. We divide the power by our index. So 10 divided by 2 will give us x to the 5th. And we can't simplify this, so that's just going to stay inside the square root. Remember, you can get rid of the 1 because you don't have to write it there. Now, we've got this 8 and this 9 here. These are multiplied together, so let's go ahead and multiply these. And if we multiply those, we'll get 72. So I'm going to have 72 x to the 5th on the outside. So I have 72 x to the 5th times by the square root of x. And this is my final answer. So remember, our main rule was we need to multiply the two numbers that are outside together. If we have two numbers outside, we won't always. We want to multiply the two numbers inside together if we have two numbers, just like this. And then if we have powers, whenever we're multiplying, we need to add our two powers together. So x to the 5th times by x to the 6th will give us x to the 11th. From there on out, it's just simplifying just like we've seen before. And if you have two numbers that are outside, you need to multiply those together. So let's take a look at a division problem, which is very, very similar. So here we've got cube roots this time, and we're going to go through the same process. Now, we don't have numbers outside other than our index, but that's not going to change. What we do need to do is we need to divide the two numbers that we have inside. So I need to divide 48 by 6. So, when I divide these, 48 divided by 6 will give me 8. We still have our cube root here, and when we multiplied, we added our powers together. Now when we're dividing, we need to subtract our powers. So 14 minus 3 will give me 8 to the 11. So here we've got the cube root of 8a to the 11. Well, we should notice if you're looking at your chart for cube roots that 8 is a perfect cube. So we don't need to split that up, so I'm just going to leave that as a cube root of 8. But this a to the 11, I can't divide my power by my index. I can't divide 11 by 3. So I need to split this up into two numbers. I need to split my 11 up into two numbers that add to 11, but one of the numbers has to be divisible by 3. And I'm going to use 9 and 2, because 9 is the biggest number that I can have that's divisible by 3, that's less than 11. So I'm going to have the cube root of a to the 9 and the cube root of a to the 2nd. Just like that. So we've got all our cube roots here. We've got our 8, our a to the 9, and we have our a to the 2nd here. So let's simplify. Cube root of 8 is equal to 2. Cube root of a to the 9, we divide our power by our index. 9 divided by 3 gives us 3, so I'm going to have a to the 3rd here. And then we can't divide 2 by 3, and we can't simplify this more, so this is just going to stay like it is. So I end up with 2a to the 3rd times by the cube root of a squared. And this right here is my final answer.